Okay, gee, that's a very, very good introduction. Thank you very much. Welcome everyone to the special panel session of this year's conference, the Financial Markets and Corporate Governance 2021 on endogeneity. This is a very important topic, of course, and I'm very pleased to be the chair of this session. I just wanted to make I have like 5 minutes and I know we're behind, but I think I've got an important little message to tell you about where I see this sitting, and I'm trying to figure out how to share my screen, and you think for the life of me, I can see, all right, share screen, and yes. Okay. Right. Hopefully you can see these. I've just got a couple of slides. To me, the underlying framework of research in the 21st century includes the tools and how we might attack endogeneity, which is obviously linked to very critically to causality, is responsible science. And there are 3 key elements to responsible science. We should strive to have credible research, so that is research which is reliable. We should strive as much as we can to have relevant research, so that is useful research, not only to academics, but to the community and non-academic sources. And we should strive to be independent researchers. So if we think about essentially empirical research, corporate governance and financial markets research, there are 3 basic building blocks: the idea, the data, and the tools. And for me, endogeneity is largely about the tools that we use. So three tips that I would put into the mix for tools generally, but I think it definitely applies to endogeneity and how we do the identification, how we try and get closer to causality, to convince people we have identified a causal relationship, is when we think about endogeneity, we should strive for contemporary tools. We should strive for gold standard tools, and we should look for endogeneity tools that are fit for purpose. So with those introductory remarks, I'm going to hand over, I believe, first of all, to Tom. And Tom has got a range of remarks to get us thinking about this a little bit more. And then I will, once Tom is finished, we'll move to the other panelists, and then we'll have some Q&A. So Tom, I'm going to stop sharing screen, and I'm going to hand over to you. Thank you.
Thanks so much, Robert. Pleasure to be here. Let me also thank Bala. Bala is an unsung hero. He deserves great recognition for all of his contributions to academia, and the founding and organization of this conference is just one of them. Thank you very much, Bala. I'm going to kick off. Mine is mainly pictures. And then the other more knowledgeable panelists are going to clean up and give you all the details. So, ready to go. So, just got to get this going. So, endogeneity is the classic problem, right? I notice in Canberra, there's very, very few police officers and there's not much crime. But I notice in New York, there's a lot of police officers and a lot of crime. The correlation is obvious, right? Let's get rid of the police officers, as a lot of the places in America are now doing. More diffuse ownership might affect performance, but firms with strong performance might attract diffuse ownership. Banks with adequate capital reserves might have good performance, but on the other hand, good performing banks might have stronger capital reserves. Athletes might develop lactic acid as their performance deteriorates, but alternatively, lactic acid might be facilitating muscles to aid performance. And in fact, that's what they found and overturned a long-held belief that you had to stop lactic acid buildup when they studied this problem at the molecular level. So, you know, the standard regression analysis in all of these cases, and many more than I could enumerate, is going to compound the effects. So it's very similar to errors and variables. So since we're, most of you are familiar with errors and variables, we'll review it, and then we'll draw out the paths that apply to endogeneity. If there is, errors and variables, measurement error, the idea is to use an instrument, and this holds true regardless for anything. For endogeneity, you've got to come up with an instrument that's uncorrelated with the error, exogenous, and relevant to the X bar. And the IV estimate is not covariance X and Y as a variance of X, but it's covariance YZ over covariance XZ. To see this mathematically, let's think of the normal equations of OLS. This is the derivative with respect to, the first equation is derivative with respect to alpha, the second derivative, the derivative with respect to beta. This implies that the beta estimate is covariance Y with X over variance of X. And if we replace X, if we don't want that anymore, we replace it by Z. We can do that because Z, the instrument, is relevant for X, correlated with X. And we can put it here in place of X because Z is uncorrelated with the error. So that gives us another way to think of the instrumental variable estimator. And of course, you can just run this in GMM. So think of a specific example. You can see that that Y2 here is measured with error, because Y2 in this first regression, you can see that Y2 is measured with error because Y2 has an error component. You can see in the second equation that Y1 is measured with error because you can see from equation 1 that Y1 is measured with error. So, so the problem is very similar to the errors and variables to measure the error problem. So if we want to run that, here are the normal equations. So the first equation defines the alpha, second one defines alpha 1, second one alpha 2, beta 0, beta 1, beta 2. The endogenous variables, I've in theory picked out these Y1 and Y2 to be the endogenous variables. In practice, we're not sure, and we treat them all on suspicion. We have to replace these endogenous variables that we've got in brackets here with instrumental variables. Here it's easy if I can use variables from the equation set, and this is going to be fully identified. I can see it's fully identified. They're all different equations. And if people call me up all the time asking about identification, the rank and order conditions you would have studied as a young undergrad. I'm sure you all studied it and regurgitated it and got your good mark in your statistics, econometrics course, but no one really understands it. So everyone calls me up asking about it. But if you do it in these normal equations of OLS, it becomes very easy. Here's another example, right? There's only X1. So we need to replace Y1 and Y2, but there's no other variables in the system. So if we put in X1 here, this equation and this equation will be the same. And this equation and this equation will be the same. So using the variables in the system, you can immediately see that this is not identified. So John Graham, I think, was one of the first to look at difference, GMM. He looked at differences and leverages way back in 1996 as the dependent variable. And so one way to look at difference GMM is, you have take the difference of this equation minus its lag, and you get the change in Y1 is the intercept goes, and you get an equation in terms of the changes. The intercept cancels out, and the error term is now correlated to this UT minus 1. Writing it up in normal equations, you have the first equation defines the alpha, second one alpha 1, alpha 2, and I'm missing one for alpha 3. And I've got it there. Alpha 1 is the intercept, alpha 2 is the second equation, alpha 3 is the third. And the instruments are from T minus 2. If you want to do system GMM, in startup, it would have the levels, and you instrument with the differences. And this is all explained by Ariella and Bond. Of course, you don't need to use their system GMM. You can use whatever instruments you like. In terms of the theoretical test, is a test for endogeneity. You might have what looks to be endogeneity in theory, but in practice, it's not important. Yeah? So the endogeneity test will show that. You need to show that your instruments are correlated with your endogenous variables, yeah? And that's normally through an F test. And you need to show your instruments are uncorrelated with the error. Hausman and Wu has this basic assumption, hypothesis that OLS is efficient and consistent. And efficient means it's the minimum variance estimator, and the alternative though is it is not, but the instrumental is the variable is consistent. So we take the difference between the OLS and instrumental variable estimates squared, weighted by the variance covariance matrix of the OLS minus instrumental variables estimates, and that's a chi-squared with the number of elements indeed. How do you test that the instruments are correlated? You regress the endogenous variable on the instruments. And a rule of thumb is an F greater than 10, but more formal tests are given by Stock and Flybergen. And the over-identifying test is just a regular J test you do with method 1. Now, if you really want to get in the big journals, you've got to come up with a really economically and intuitively motivated instrument. Some of the other speakers are going to be talking about that in the talks that follow. My favorite, and the only one I really think really works, is the sex of the firstborn, used in determining the effect of family succession on firm performance. And that's by a friend of ours, Casper Nielsen, who's at Hong Kong. So the idea is, what is the effect of family succession on performance? So the idea was to use as an instrument for family succession the sex of the firstborn. And the idea, if it was a boy, it was more likely to be the family succession. Okay, is that uncorrelated with the error? Well, it's unlikely that, you know, a random occurrence 50 years ago affects the performance of a firm now. And is it correlated with family succession? Well, unfortunately, true, right? And a lot of societies, if the firstborn is a male, there's more likely to be a family succession. Okay, the pretty pictures. We're looking at ownership, inside ownership, and performance. Company A has got its equilibrium, its optimal at 3%. Company C has optimal relationship at 5, and company D at 7. And that's the equilibrium for each firm. So this is actually what's going on in theory, but a Senate committee requires a study to examine ownership performance relations. And some really good researchers from Chicago go out and fit a relationship. They find it increasing to about 5%, declines, and pops up somewhere out here at 20%. The Senate committee says that's very convincing. Let's make everyone have ownership of 5%. Yeah. So doing that, what happens? Well, you see that this is the drop off. Yeah. For C is fine, but A drops off by this much in its performance, and B drops off by this much in its performance. What would you do? What would you get if you went and did the test I just showed you? Yeah. What would you get? Would it rectify this problem? Well, no. In theory, what you get is the instrumental variable. If you've done it the right way with instrumental variables, a really good instrument with system GMM, you'd get a flat line. You wouldn't get a bad result. You wouldn't get the incorrect result, but you'd get a flat line. And of course, that's just the nature of endogeneity. And this guy Kemsick told us all about that in 1983. If you've got an endogeneity problem, you've got an endogeneity problem. You're not going to get around it. Yeah? And there's follow-up papers by Kemsick and another paper that one of the other speakers is going to talk to, which I really like, the Paulson and Menschke paper. So how really then do you get around it? Well, you have to do a natural experiment. And my favorite paper here is the one by Hyder and Lindquist. So they went and hand collected the state taxes. In the US, they have federal taxes as well as state taxes. So the exogenous shocks, yeah, the changes in state tax were used to get around the endogeneity issues. And there were hundreds of them. Yeah? There was 38 corporate tax increases and there were 67 corporate tax decreases. And the paper goes to a lot of trouble to show that these were exogenous changes in tax, nothing really related to what was going on in the state. Yeah? And there is a positive relationship between increases in taxes and leverage, but not for decreases. Yeah? And look, I think of that as it's easy to issue more debt, right, in response to a tax change, but it's quite, it's more sticky to pay down your debt. So the effect for the tax cuts might be more in the future. So that's really an outstanding way to go, right? The way to do with endogeneity is find the exogenous event, but of course, even better to find 100 of them. Yeah. And Graham did a very sensible study of debt and taxes back in the 90s. So I think this is the fulfillment of this, right? This is probably the most sensible paper yet. And it gives you a roadmap to your own research design. Why is that important? Well, this is what the editors are looking for. Yeah? So they don't want to see two-stage least squares anymore. They want to see at least instrumental variable system GMM. That's probably only going to get you into an A journal. If you can go further and come up with a really good, intuitive, economically motivated instrument, that's probably going to get you into the A star, but that's very difficult. If you look at the examples I gave you, it's very hard to get some. What they're really looking for is a natural experiment. In that natural experiment, you can do a different dip amongst what happened before, what happened after, and you've got treated and you've got untreated. I think that's about all I've got. The other speakers will cover a lot of what I've done in a lot more detail. So I'm going to stop sharing here and hand back to Robert. Robert, we can't hear you. I think you're muted.
Sorry about that.
Robert, I think I need to come out there as your executive assistant.
Yeah, that's right. Yeah,
I work for nothing.
No, appreciate it. No, what I was saying is thank you very much, Tom. I budgeted more time for you. I found it easy to hear you with the earphones on. I also forgot that I muted. I do apologize. All right, so that's given us food for thought, definitely. So very good start, but I think we're going to go from strength to strength. Now, what I don't know, and it looks like Nadia being unmuted might want to go next, but I really need guidance from either you or Lalitha as to who thinks they would be the best person next. Do you want to go next, Nadia? Oh, I think I can't.
I can't hear you, Nadia.
Can't hear you, Nadia. Good, I'm glad I'm not the only one. Still can't hear you. You don't look like you're muted, though, right? Still can't hear you.
Can you hear me now?
Yes.
Yes.
Perfect. Thank you.
Perfect.
All right, perfect.
All yours.
All right. Okay, thank you very much. Tom, very good start. What I'm going to do, I'm going to take you back a few steps to the basic origin of the problem of endogeneity. And it will connect very well to Tom's speech and to Lalitha afterwards. So I'm going to go to basics. First, I'm going to introduce definition of endogeneity, and then I will also reflect on 3 reasons of endogeneity and possible solutions. And Lalitha will complement that by providing some really interesting examples and papers to look at. So let's look at the definition of endogeneity. So I'm going to go back to linear regression and complement what Robert started with to ask, what are we after as researchers? We're trying to explain our world. We're trying to do independent studies and to explain specific phenomena in our world. Given my focus in corporate finance, I'm going to give some corporate finance example. For example, the researcher would like to look at firm choices regarding capital issuance as explained by investment opportunity. So basically, if there is sudden random changes in investment opportunities, how I would finance those investment opportunities. So these kind of questions we are after as researchers. So in other words, we're trying to see how capital issuance can be explained by the investment opportunity, which is X. And both Y and X, which is investment opportunity and capital issuance, are random variables. Let's go to random variables. What we mean, we know statistics very well, and statistic can help us finding kind of relationship between those random variables. So the capital issuance Y can be explained, find the expected value conditional on the investment opportunity, which is X. So, and this is what we call the expected value of Y given X. And additionally, in words, what we basically saying by writing this, borrowing this from statistic, we're saying Y has two components. Part of Y explained by the investment opportunity, or X, and the other part is everything else sitting in what we call the error term, or epsilon in this scenario. Okay, so there are two components, and we need to be careful about those two components. And this is also in statistics what we call conditional expectation function. And this conditional expectation function has very desirable properties. So it is natural way to think, basically this CEF is natural way to think about relationship between Y and X. And also it is the best predictor of Y given X for the minimum squared error. This is basically minimum squared error. So we minimize the error term and we try to get the part that related to X. Okay, so this is by definition when we borrowed this regression from statistics. So if you want to look at this expected value of Y given X visually, this is basically what we have. What we're saying here, for any value of X, the expected value of Y has centered distribution of EY given X. So this is visually what we mean. In other words, this expected value of Y of X should have this kind of format given different value of X. And this different value of X is really important. And this is basically the reason that could create issues for us. So what is so great about linear regression? Why we use it very often? Because it can be proven that the beta X is the best linear prediction of Y given X. And also it is best in terms of minimizing the mean squared error. So this is quite useful. Even the relationship between Y and X is not linear. Even when we use linear regression, it gives us the best estimate linear relationship. So it still works even we don't have the exact relationship linear. So what about causality? So now we know linear regression is great, giving us lots of insight. Can we extend the linear regression and talks about causality? Now when it comes to causality, we need to be careful. We need to be careful how X explains Y. We need more assumption to say that X causing Y. What are these assumptions? There are two components of this assumption. The first assumption is the error term, expected value of the error term is equal 0. So this is not an issue. We can do it by adding the intercept, right? Now, suppose that the error term equal to a constant. It's equal to K. Is this a problem? That's not a problem. As I demonstrate here, we can rewrite it and will be observed by the intercept. So that's not a big deal. Let's go to the next assumption. The next assumption basically, and this is the important one, we would like to have the error term. So Y has two components. the expected value of y given x and the error term. So we want to make sure that the error term is not correlated with the x. In other words, the value of the error does not dependent on different value of x. That's basically what we're trying to achieve, which basically saying the expected value of the error given to x should be equal to the expected value of the error. Okay? So, and this is what we call conditional mean independence. Okay? So this is true if x and the error term are independent of each other and they're not correlated. And this is the key assumption being made when we make causal relationship between x and y. So when we say the change in x will cause a specific change in y, we're assuming this relation, this second part of the assumption hold as well. So basically what we are saying as well in terms of the conditional mean independence, and this is the most important part, what we're saying, an increase in x from a to b equal to the change also in expected value of x given b minus the expected value of y given a. Okay? So that's basically, if this is satisfied, then the error term is okay. Okay? And this is only true if the expected value of the error equal to x, conditional on x equal to the expected value of the error. Now, this is what we require. Again, I repeat, this is basically what we want to satisfy to draw causal relationship between x and y. Example violating, like here I'm going to give you some example why this causal relationship can be violated. I'm giving you here example, as I said at the beginning, corporate finance. Look at, let's look at variation of leverage for given changes in profitability. Okay, so let's look at stories that could tell us that what we looked at before, given different value, if x moves from a to b, we can make reasonable prediction about the value of y given x equal to a minus y given x equal to b. Okay, so let's look at the theories here. We have many theories. Capital structure theory saying if unprofitable firms tend to have higher bankruptcy cost, implies that the unprofitable firm should have lower leverage. But we can look at another theory that could also contradict that this relationship of the value of the error not correlated with x is the pecking order theory, where basically unprofitable firms have accumulated less cash, and this implies should have more leverage. So both of those theories contradict that the error term is independent of x. Now what I did so far, I just used the theory to say that this condition might be violated. That's the question. Is there a way to test this conditional mean independence? In other words, the error term is not correlated with our explanatory variable? No, we cannot. It is only by, similar to what I did, using theory to show it can be violated. Okay, so we cannot provide a test to show that the CMI is violated. And this is what we call, when you send your paper to JF, JFE, top A-star journal, they basically, we call them the identification police. This is what they're after. So, so basically when they say you have identification problem, what they are referring for is basically that the X is correlated with the error term. This is basically the identification, and this is what they refer to. And basically, researchers to need to find ways. We need to be innovative as a researcher to find ways where we can ensure that the error term is basically independent of our explanatory variable. Okay. So let's look at, this is basically just the crux of the problem. Let's look at 3 reasons of endogeneity. And Tom talked about few as well. So I'm going to talk about 3 of them. They are the main ones, I think. And I'm not sure if Lalitha, I looked at your notes. I don't think you have different ones. The first one is omitted variable bias. And this is a big problem for omitted variable bias. Basically, so this is only a problem if it is basically affect the relationship of X with the error term. Sometimes omitted variable does not affect the relationship of X with the error term, and we are fine with that, okay? It is only a problem if it affects the relationship or the correlation between the explanatory variable and the error term. And I give you here an example, which is a relationship of wage to education level. The problem is the omitted variable here in this equation is the ability, because ability could reflect in education and achievement as well, and which affects, of course, which basically saying the education could be correlated with ability, which affect the error term as well. Okay, so in this scenario, the omitted variable can be problematic. I see very often when I referee paper, what they do with the omitted variable, they say, oh, we control for this. They add variable to the regression. Adding variable, control variable will take care of endogeneity. It doesn't. It doesn't take care of endogeneity. You need to be more innovative to address this issue. Second reason is measurement error. Measurement error usually is a problem only, again, you could have some degree of measurement of error. And if it is only a problem, if this measurement error will be correlated with X, and which causes X to be correlated with the error term. So I'm going to give you here example. For example, leverage. Here, leverage relationship between leverage and profitability. Leverage, we know leverage, usually as a researcher, we all go to CompuStat and we use the book value of leverage, not the market value of leverage, right? We approximate the market value of leverage using the book value. Now, the problem is this leverage, there is a measurement error, but the measurement error depends on the profitability of the firm. So when the firm less profitable, we're gonna see bigger gap between the book value and the market value of their debt. Do you see? So in this scenario, even the leverage was in the dependent variable, affected the dependent variable and affected the correlation between the dependent variable and the error. Okay, and these are the cases where measurement error could be problematic and we need to address. Another reason for violation of this conditional mean independence of the X with the error, I keep repeating it because I want especially young researcher or junior researcher to have this in mind, and after finishing this session, which Tom also reflect on, which is simultaneity problem, where we have basically system of equation. And the famous one when we took our first introduction in economics is the demand and the supply function, where the pricing and the quantity function are related to each other. And this is what I have here. The pricing and the quantity function are related to each other, and this is where the two variables are determined jointly. And that's also, it creates similar problem. So what are the consequences? This is just touching in general on the reasons. Now, what are the consequences of endogeneity? As maybe some of you heard from the referees, from the editors, and from all the rejection you get, the parameters are unidentified or biased. So impossible to draw a conclusion about causality and interpret results in the way you intend to create a research question or answer a specific research question. Now, what are the possible solutions? I'm going to touch on them lightly, and I'm going to give the ground to Lalitha afterwards to expand more on this by providing examples. So the possible solution, which was very popular when I was a PhD student, is to use a structural approach. Structural approach creates system equation and estimate the parameter of the model. And this is like you can think of it as a utility function and solving the maximization of, for example, profitability of a firm. The other one that we use, this is more, I see the structural approach is more economics, but we have Hansi and Whited wrote very good papers about it, and they made a career out of this. The other one is to use the reduced form approach, which is more common now in finance, where we need to find some exogenous variation. We want to find random independent exogenous variation that could affect the X, but not relate, should not explain any of the Y. So that's the exogenous variation that we're looking at. Example of education, education and salary that we talked about, because the education is related to the ability, and so we want to find somehow something to explain in the education independent of the salary. So where does one find exogenous variation? You need to get good data. You need to understand institutional details. Very important to understand institutional details. Tom reflected on the tax structure to explain leverage, for example, or capital structure, that basically understand the institutional detail. Additionally, you need to understand economic mechanism, theories, for example, that could help you find those exogenous variation. So one way to do it is, as my colleague at Melbourne Uni, Peter Bozart, do experiments. He only believes in experimental research, not empirical research. So sometimes it's possible to do experimental research, and there is a big field for it in economics and finance as well. But in some situation, those experiments not ideal to answer the question. We go back to the education example. Can we run a random experiment where we allocate kids to specific education randomly? Ideally, like we would love that, but it's not feasible to do it. So that's why actual experiment may not work in answering some research questions. The other simplified version of pure experiment, we can use natural experiments. And there are many examples of the natural experiments, and Tom reflected on some. And here I'm gonna go back to the education and salary. So this paper by Angrist and Kroger in 1991 tried to address this issue. And they found actually, they looked at some basically structure in the education system where kids get enrolled in the school, especially in North America, in the fall, basically at the beginning of the fall. And you see variation in the age of the student when joining the school, and also there are some regulation on when kids can drop out from the school, okay? So in other words, the amount of education can vary based on the age rather than ability. And they use the instrument, which is the quarter of birth, as on education. So this is one example how to use natural experiment, and in this scenario, used instrumental variable. The other approach, difference that Lalitha will talk about. So I would like now to finish my discussion and give time for Lalitha to to give us more example to solidify the concept I discussed briefly here. Thank you.
Thank you very much. Yeah, I think I'm not muted now. Thank you very much, Nadia. That was a great follow-on from Tom. Tom set the bar high. You took it higher, and I'm very confident Lalitha is going to just take us to the stratosphere. So the way I look at it, we're doing very well with time. So Lalitha, I hand it over to you, and I'm looking forward to your contribution.
Thank you, Robert. Let me just start by sharing my screen. All right, everyone. Good evening, I guess good morning, sorry. And it's a real pleasure to be here. Thank you, Bala, for inviting me to be on the panel. I should start by saying that I am not an expert on either econometrics in general or endogeneity in particular by any means. But as all of us who work in the area of corporate finance and particularly corporate governance know, we are forced to confront this issue sooner rather than later. So we have to grapple with this and kind of learn how to deal with it. So here's a great reminder of why endogeneity is important. So we know in typical papers that we would like to show causality, that X has a causal effect on Y. But as Nadia's last slide mentioned, we know that correlation is not causation, and here's a great reminder that we cannot misinterpret the results. So what exactly is endogeneity? It is where the variable of interest, so my slides are going to be way less technical than Nadia's and Tom's. I should tell you that up front because I am way less technical than them. But hopefully this will be a different way of looking at things. So where the variable of interest is correlated with the error term. OLS assumes that the correlation is zero, so this creates a problem when we try to interpret the coefficients. What are the causes of endogeneity? Well, it could be omitted variable bias, omitted variables, it could be simultaneity, or it could be measurement error. So I'm going to talk briefly about each of these. My last slide concludes with a great set of references, particularly Roberts and Whitehead is a really terrific reference on endogeneity. I strongly urge anybody trying to understand this topic to start with that paper. So what exactly is the omitted variable problem? It is when we estimate an equation, say y equals some function of x, when the true equation is y is x plus also a function of some omitted variable. And this variable that should be included is not included either because we did not think of it as a researcher or more typically because it's unobservable. So what happens when the omitted variable is uncorrelated with x, as Nadia said, inferences are unaffected and OLS is still valid. But when this omitted variable is correlated with x, our OLS estimates are inconsistent. Here's an example of an omitted variable problem where we have a regression of firm value on CEO ownership. And firm value also is a function of firm size. That is an omitted variable in this regression. Now, if we had estimated a negative coefficient on CEO ownership, we would have concluded that higher ownership reduces firm value. But it could just be that because we've ignored firm size and we know CEO ownership is most likely a function of firm size, omitting this variable that is correlated highly with one of our X variables creates biased estimates. The second kind of issue that causes endogeneity is simultaneity. Here, X and Y both are determined in equilibrium. So we could argue that X causes Y, or in reverse, Y causes X. Here's another example of that, where we're saying firm value again. Let's say it's a function of ownership. Let's say we've concluded that beta 1 is positive, so higher ownership is associated with higher firm value. But it could simply be the case that CEOs of high value firms chose to keep higher ownership. So as long as both firm value and ownership are determined endogenous and in equilibrium endogenously, we cannot make inferences using this first equation here. Robert and Whitehead, the paper I mentioned, actually give a great example also. They talk about firm value. estimated on entrenchment index. So this is a very classic variable in finance. And typically papers have found that this beta 1 is negative, which indicates that high levels of entrenchment are associated with lower firm value. But it could be the case, and this is what subsequent papers have found, is that CEOs of low value firms choose high levels of entrenchment in order to protect themselves. So our original inferences just made with this first equation would be incorrect if we don't control for the endogeneity. And the third kind of issue that causes problems, endogeneity problem, is measurement error. So either Y or X is measured with error. If Y is measured with error, this is similar to an omitted variable problem. Our OLS estimates are consistent if the measurement error is uncorrelated with the X's. If X is measured by error, then typically our OLS estimates are biased. So again, I turn to the Roberts invited example for this. And this is again, very classic example in corporate finance where investment cash flow sensitivity literature estimates this equation. The dependent variable is investment at the firm level. The independent variables, key independent variables are Q, which is supposed to proxy for growth opportunities of the firm, and cash flow. And suppose Q measures growth opportunities with error, which is what has been argued in the literature. We also know that cash flow is positively correlated with growth opportunities. So as a result, what happens is that the beta 2 coefficient is biased upward. And so even though in truth, there need not be a relation between investment and cash flow, because of this measurement error problem, we are estimating a beta 2 that is positive. So this is something, again, that we need to address. So how to deal with endogeneity? There are a lot of ways of dealing with it. The most important methods are what I touch upon, or the most common methods, I should say, are what I touch upon. Fixed effects regressions, natural quasi-natural experiments, and instrument variable approach. So fixed effects is kind of a more simplistic approach for dealing with endogeneity. It filters out any time invariant unobservable variation in a panel setting. And so an example of this is Adams and Ferreira. They, in their 2009 paper, say that they use firm fixed effects to address the concern that omitted culture or any other time invariant firm characteristic is driving our results whenever possible. So most papers that you see today in corporate governance automatically include fixed effects to filter out some of this. But of course, we know that not all the variables are vary only with our time invariant. So we have problems that fixed effects cannot really fix. So another way of dealing with endogeneity, Nadia mentioned this, as did Tom, is natural and quasi-natural experiments. Here, this is where you have an exogenous shock to the variable of interest. And this is typically caused by changes in some kind of regulatory environment or the economic environment. Here, the methods used include diff in diff or difference in difference, DID approach, also instrument variables, which I had alluded to earlier, and also regression discontinuity design or RDD approach. Here's an example of a paper, the Ahern and Dittmar paper, which uses a natural experiment, a quasi-natural experiment, to answer the question, does gender diversity on boards impact firm value? And typically this has been a problem because both gender diversity and firm value are endogenous. But what they do is take advantage of a Norwegian law that required a minimum number of women directors on boards of Norwegian firms. And then they used a difference in difference approach to show that the effect of adding women was actually negative in their case. Another example of a paper that uses a DID approach in a quasi-natural setting, experimental setting, is the Gormley, Matza, and Milburn paper. They look at the effect of firm risk on CEO incentives. Does firm risk impact CEO incentives is one of the questions they're trying to answer. And again, here you can easily imagine both CEO incentives and firm risk change endogenously. So the way they do this is to look at an exogenous shock to firm risk, the exogenous shock they exploit is when the firm's employees, a certain fraction of them, are exposed to a chemical that is actually later added to this list of carcinogens. And so they say that this, at time 0, when it's added to the list of carcinogens, subsequently you can see that the exposed firm's risk is much higher than the unexposed firm's risk. But before this, you can see that both firms, the blue line and the gray line, are the same, or they overshadow one another. So they're really, before there was no difference in risk, but after you can see a sharp difference. So they take advantage of the shock to risk. Dealing with endogeneity, another way of doing this is also the regression discontinuity approach, or RDD approach. Here, essentially what you're doing is that firms on one side of some arbitrary threshold are subject to a shock, while firms on the other side are not subject to the same shock. And here you could argue that the assignment to the treatment may be considered truly random for firms that are very close to the threshold. So one example of this is the Iliev paper, 2010 JF paper, where he looks at the effect of section 404 of SOX, which requires firms with a public float more than $75 million to start filing management reports that are attested by their auditors. For firms below the 75 million threshold, the requirement is postponed by 3 years, and eventually they actually drop the requirement altogether. But at this point, they postpone the requirement by another 3 years. So when Iliev looks at this, he is trying to figure out what is the impact of this additional requirement on firms. And so he looks at this firms that are very close to the 75 million threshold. The idea is if you're very close to the threshold, you should not really differ in much except for the impact of the shock. And therefore, looking at what happens to the treated firms after the shock gives you a very good idea of the true impact of the shock. That's the idea of the RDD. The things to consider in an RDD would be, what is the strength of the shock, right? Do you really see a jump? In this case, in this example, what the RDD is affecting is the filings by firms. And so do you really see a jump in filings around the shock? So is the shock strong? And Iliev shows that it is indeed a very strong shock. The second thing that is important in an RDD is to look at the bandwidth. And the bandwidth here that you consider is how close to the threshold are the firms you're choosing. Obviously, there's a trade-off here because the closer to the threshold you choose firms, in this case, Iliev chooses firms that are between $50 and $100 million. So 25 million on either side of the threshold. But the closer you are to the threshold, you are losing a lot of firms because your sample size shrinks. But the benefit is that you can call the assignment truly random. The further you are from the threshold, the less chance that this assignment is random. And the third thing to consider in an RDD is, can the forcing variable, in this case, what we call the forcing variable is the public float, right? That is what forces you into treatment. And so can the forcing variable be manipulated? Because if it can, then obviously you have a problem, right? So these are the things that you consider key things. There are others that you would consider, but these are some of the most important things you would consider when you're looking at an RDD design. There are also papers that deal in general with exogenous shocks. Not specifically, you couldn't call it a quasi-natural experiment, or at least it is at the firm level, not in a general economy level. So for example, Massoud and Zhang, they are interested in looking at the effect of board independence on firm level outcomes. And so what they look at is an exogenous shock to the supply of independent director services. The way they do this is to look at personal distraction of independent directors, illness, injuries, etc., which are arguably exogenous. Also professional distraction. So is something happening to, if there is a director on your firm who's sitting on another firm, the interlocked director, then does something happen at the interlocked firm that increases the distraction level of this director? So they're looking at personal and professional distractions. Similar paper is Falato, Kaderzova, and Nell, where they are looking at the effect of director busyness on firm performance. As an exogenous shock to busyness of the director, they look at what happens to the boards of the interlocked firm. Is there, for example, did the CEO of the interlocked firm or one of the directors in the interlocked firm die? In which case, your director is now increased busyness level, and this is purely an exogenous shock. So they look at more clever experiments to look at shocks to firm level that cause firm level variation, right? And in general, when you're dealing with exogenous shocks, the questions we ask ourselves should be, is the shock truly exogenous? So for example, the treated firms could have lobbied for the law change, right? Exogenous shocks are typically, people look at what are the results of some regulatory change. So maybe some firms that stood to benefit lobbied for it. So then if you look at the treated firms and say, hey, there are benefits to this treatment, that would be an incorrect conclusion or a premature conclusion. And then if the shock is truly random, the sample and control firm should be similar on as many dimensions as possible pre-treatment. So a lot of papers that look at exogenous shocks compare the treated and non-treated firms, control firms, on a number of dimensions pre-treatment to show that they are similar. You also typically do a parallel trends assumption to show that treated and comparison groups may have similar trends in the pre-treatment outcomes. So this was kind of similar to what we saw with the Gormley paper, right? So pre-treatment, you saw that they kind of looked the same, but post-treatment, you saw that the difference was there. So this parallel trends is an important thing to show when you're looking at the effect of natural shocks. You can also experiment to show more conclusively. You can experiment with placebo shocks. So if the actual shock happened in 2001, then maybe the control group is in the period 1998 to 2001. So you can pretend that the shock happened in 2000, or the shock happened in 99, or the shock happened in 98, and see what happens to your conclusions. And is the shock isolated, right? Is the shock specific to only the variable you're studying? So for example, SOX changed the requirement for board independence, majority board independence in 2002. But around the same time, NYSE and NASDAQ also mandated changes that required majority of board independence, but also 100% independence on the nominating, audit, and compensation committees. So if you are looking at the effect of SOX and you're looking at post-SOX, well, there are these additional regulations that also came into play, and you should be able to isolate that this is purely the effect of SOX. So that is something that you need to be careful about if you're shock isolated. And here are some, dealing with endogeneity, you can also use instrumental variables approach. As I said, these instrumental variables approach either can use the natural shock itself as an instrument. So for example, the last paper here, Duchin, Matsusaka, and Rosbas, use SOX, non-compliance with SOX as an instrument. So they're using the natural shock as an experiment to figure out what is the effect of board independence on firm performance. So the shock is a shock to the board independence. But other papers use more specific instruments. So for example, Bernil et al., they're looking at the effect of board diversity on firm risk. And they're trying to instrument for board diversity by looking at diversity in a pool of potential director candidates that are within one nonstop flight from the headquarters. Similarly, Adams et al. In their 2018 JFE paper are looking at the effect of skill diversity on firm performance. And as an instrument for skill diversity, they look to see whether the firm is within 70 miles of an airport hub. The idea is that directors may not be willing to travel long distances. So if you're within 70 miles or 1 hour driving of an airport, you're more likely to have greater skill diversity. That's the idea. A good instrument should satisfy the relevance and exclusion condition. What is a relevance condition? The instrument is relevant to explaining the endogenous variable. So in this case, you would show that having an airport within 1 hour driving distance of the airport hub actually does have an effect on skill diversity, actually increases skill diversity. So the instrument affects the endogenous variable. The the relevance condition essentially is saying the partial correlation between the instrument you've chosen and the endogenous variable that you're actually instrumenting for is non-zero. The exclusion restriction, on the other hand, says the instrument should be uncorrelated with the error term. In other words, the only way the instrument can have an effect on the Y variable is through its effect on the endogenous variable. And of course, finding these instruments is very, very hard. I should say I'm not at all clever in finding good instruments, so I rely on all other papers to kind of give me these ideas. But at the same time, we run the risk of using the same instrument for proxying for board diversity, board composition, board size, etc. So that's another thing to watch out for, that you're not using the same instrument as a proxy for 10 different variables. So the references that I have here are really good references for anybody who's interested in reviewing endogeneity. Thank you.
Great, thank you very much, Lalitha. You've fulfilled my expectations, they're very high. That was a nice compliment to the other two discussions, which, as you said, were more technical. So I think as a package, the three sets of comments are really good, really fantastic, and you know, pretty comprehensive. So I'm a bit nervous, although not really, that the three panelists have done such a fantastic job that we're going to be struggling to find some questions. But you know, I'm sure I'm going to be wrong. Now, while the audience ponder what questions they might have, and maybe so I've got the chat open, looking for questions that are typed, but I guess what we could do is, okay, now we've got this Slido thing. I don't know how to use Slido. But maybe if someone, looks like someone's showing it over there, that's probably pretty good. So the top three questions are, right. So,
I can do it, Robert. I can do it.
okay.
Okay, so the first question is from Hamid. So the question is, have there have been many advancements to the typical diff and diff approach? For instance, some scholars have employed diff and diff methods. In other words, is the baseline DID approach still optimal in the eyes of the reviewers? So basically, they're talking about the regular diff and then diff and diff. So there is a, like, you know, 3 interaction instead of 2. So is the 2 interactions still like, you know, it's acceptable? That's what the question, I think, is about.
Okay, I can start this and answering this. So it's very hard, like diff and diff is a very acceptable approach, but the level of diff and diff depends on the research question you're asking. So maybe you want to start with diff and diff, and if the data allows you to go further, I would suggest to consider at least 2 levels of diff and diff. Good source of diff and diff analysis Lalitha provided with the Tom Gormley actually notes on the diff and diff analysis, and he shows variation of diff and diff. The basic one and the advanced one give you more insights.
Okay, thank you, Nadia.
So I think I can take over. Yeah, I think I'm going to do my job. Sorry, okay. I can see the screen. If you leave the screen there, I think I can do this. So, okay. So the next question that seems to at least have one like, so we're going to go for the most popular, is to do with propensity score matching. So propensity score matching is rarely mentioned in talk. Does it mean it is not regarded as an appropriate method to deal with endogeneity anymore? Does any of the panelists want to take up?
So can you hear me, Robert?
I can. Yeah.
Can you hear me, Robert?
Yes.
Okay, so with the diff and diff, the editors now like you to not just do a standard diff and diff, they'd like to see a propensity score matching with the treated, untreated ferns, right, where that is possible. So that's sort of become now part of what's required in the really top journals for the diff and diff analysis.
Any of the other panelists want to buy into that one?
So I would say the paper I mentioned, Roberts and Whitehead, also talks about propensity score matching as a good way of controlling for it. I have personally not used it in many papers, but I understand it as a shouldn't be your main method of addressing endogeneity, but as an additional method, it would be acceptable, is my understanding. This is purely based on what I have seen in papers and advice given by referees, that's all.
Well, I use propensity score matching very often in my research, but complementing the diff and diff as Tom mentioned.
Exactly.
Yes.
All right, so I'm going to go, so Christo has a couple of questions here, so I think, and I have a question or two, but I'll just see whether we have any more online. So the discussion about OLS assumes that OLS is the right model. Why not employ models where we allow the error term to be correlated with independent variables? Our research deals with social factors where this assumption is too restrictive. Any of the panelists want to buy into that one?
Well, I guess that's the whole point of what we're doing, right? We want to have a model where the error is correlated with the explanatory variables, and that's why we're doing instrumental variables or the natural experiment. Yeah. So the OLS in most cases is a straw man. Of course, the error is correlated, and we're talking about ways for you to implement models where the error is correlated. Right? That's the thrust, I think, of the presentation. Endogeneity is about using models that take account of the error being correlated with the independent variables.
Christo has a follow-up. He says, while a natural experiment is desirable, it's also a good idea to employ more robust methods in OLS. For example, random intercept and coefficients from the same regression. Yeah,
that's capturing the dynamics, right? And that's the whole idea behind like the difference GMM is to try to differencing equation is to try to capture the dynamics. And if you want to capture even more dynamics, then you can go for the changing coefficients. Yeah, that it gets a bit hairy though in the context, but yeah, you can try to do that. I know in some of your own work, Robert, you have the coefficients as a functional form of some other variables as well. And you're really trying to capture the dynamics of, a lot of what we do in estimation is sort of stylized, right? We know we're just getting, a representation of reality. We know that in practice, things are a lot more dynamic than what we model.
Maybe I'll chip in with a question of mine while we see what Slido might present from the audience. The question I have, I think, has been touched upon by at least one of the panelists, but I'd like to explore it just a little bit more. And it's sort of thinking of situations where it's legitimate and meaningful to in a sense, forget about endogeneity, or at least feel comfortable that while we'll never cease worrying about it, there situations where we sort of are a little safe. And let me throw in one type of thing that I've got in mind and then get the panelists to react. So it seems to me the maturity of a research question has a role to play. So if we're lucky enough to get on board early with a research question and everyone says, wow, that's like super new, it's a green field, and it's possibly super challenging to get to causality. If you're at the beginning of the line, you can relax. Whereas if you have another dip in the capital structure, sort of pool of research, the bar is so high. The panel, what do you think?
So the editors, you've got to get past the editors, and they've got in their mind that they want to see you address endogeneity. It doesn't matter whether it's new or it's a 10,000 paper. The editors, and you're one of them, Robert, is going to insist that you at least address the endogeneity question. You just can't write a paper now, especially in corporate finance, without endogeneity issue?
Well, the sort of paper I've got in mind is something that's more descriptive, that I guess the leading lights in the field would get away with it. I mean, I take your point too. Nadia or Lalitha?
Yeah, I think what you're saying, Robert, is just, I want to tell a story. I don't want to draw causality. Then if you are just telling a story without drawing causality, it's okay. And that's basically what the regression, the ALS, is providing to us, telling stories, but we're not drawing causality. So if this is the target and you are exploring a new area, you can get away with it. But most of, if you want to look for top application, it can be sometimes very often, not sometimes, very often questionable. But I agree, sometimes we want to tell a story. We're not drawing any causality and just understand what's going on. But you need to understand and address the limitation of why you're writing the paper.
I seem to recall a keynote address by, and I hope I got this right, and I apologize if I've got it wrong, my recollection is not perfect. Keynote address by, I believe, David Dennis, probably the best part of a decade ago, so a lot's changed since then. And the thrust and the theme of his talk, which, as I recall it, was around causality and endogeneity, was, yeah, sure, as a research industry, we should never forget about it. It's going to be super important, et cetera, But I seem to recall he had a message then of saying, well, but don't be so preoccupied with that you think the only worthwhile research, the only research that tells us something about how the world works in our field, it gives us reliable knowledge, new knowledge, has to have this, that there are going to be sort of situations when we can be a bit more relaxed about it. So I'm trying to see here, we've got 3 that have 1 tick, so I think I'll start. They're all anonymous. If actually it's moved, so in specifying a particular null hypothesis, are we interested in estimating the ATE or the LATE for statistical inference? LATE, so I guess it's, oh gosh, I wish I could remember.
What the treatment, I think.
What's the acronym stand for? I'm sure do we know what that acronym stands for?
I think average treatment effect.
Okay, yes.
Yeah, and the L, I'm not sure.
Local average treatment.
Yeah.
Anyone want to buy into that?
It depends on the theory that you're teaching, that you're testing, right? Is it an equilibrium model, or are you you're looking at epsilon changes? We all know, a small perturbation can take you completely out of equilibrium. So are you looking for an absolute change, or are you looking for a local change?
All right, and then the comments that follow that seem to be somewhat related. If I go to the bottom, if the edit suggests using a fixed term effect, the result will no longer be desirable. What can I do to save the situation? Oh my gosh, before I let the panel in, what is our goal? Our goal is to uncover the unknown truth, or at least some evidence that will give us confidence that we understand the world better. Our goal is not to get a significant result if it's contrary to what is the unknown truth. So what I would say with that particular one is, please align your goal to what I would say is responsible science. We want to be responsible scientists. We only want to identify and find some evidence where we believe it relates to the truth.
Well said, Robert.
So answering this question is an interesting question, and I think all of us you have to be honest. If the text effect is basically important for your test and it's not there, then maybe your result and your research question is not valid. I understand you want to save the situation, but you cannot save the situation for the wrong reason. My take usually, if I get comments like this, I can find alternative way to address, alternative tests to address similar issue, and I will be honest in my reporting as well. So if the results is not there, it's not there.
Tough. The incentives that we have, the way the world works, can push us down a dark path. And I think the way of the 21st century is we have to be more honest. That's not to say everyone's dishonest. You know, the vast majority of people are trying to do the right thing. But what can get in the way is we do things fooling ourselves that we're doing them for good reasons and right reasons, when in fact, we really not. Sorry to come in hard and heavy here. Is it advisable?
Can you highlight the question you're answering, because I still see Linda as the question. Yeah.
Yeah. Well, it's still in. I suppose I've taken a broader perspective on the question, which is, you know, if you've heard, and sorry, Linda, I'm not attributing this to you, but p-hacking, right? So we don't want to engage in p-hacking. We don't want to try the next, you know, we keep trying to do these different techniques. You know, there's even enough menu available to us with treatment for endogeneity. We can find one that works. And I'm not saying that Linda or anyone is doing that, but it can happen, and we don't want to be p-hacked. So let me, so the bottom one, is PSM the best, and Tom might have answered this, I don't know. Is PSM the best way for matching? So there's novelist distance. Does anyone want to?
So you just get a score from the PSM, and then there's many different ways of matching the firms, right? So there's lots and lots of, some people do closest, some people use different measures of distance, but there's many different ways of matching the firms based on the propensity score. Yeah, so there's a whole literature on that. So the PSM is just a score, and how you match it is, there's a large number of ways of doing it. And it's probably best to have a look at the literature.
Right, there's one at the bottom of the screen. Is it advisable to use a large, where is it? It's gone. Oh, there it is. Yeah, right. Is it advisable to use a large pre-treatment and a small post-treatment in VID estimation?
Well, it's always good to have as big a sample as you can. If for some reason you believe that the structure has changed over time, then you might want to look at a financial year before and a financial year after. But if you're satisfied that you've got the same unconditional distribution over time, then always better to have a larger sample than a smaller sample.
I think also to add to that, I think in most cases where we are looking at DID, we're looking at the effect of a shock. And everybody's off to the races to try and be the first one to come out with a paper looking at the effect of the shock. Like, for example, now California introduced a law for board gender diversity. And so everybody wants to study the effect of the law on firm value or some firm outcome. And so by necessity, your post-treatment sample is small because everybody wants to be the first. And this happened when option expensing, for example, there was a Hayes paper in the JFE, which looked at the effect of FAS 123R on option compensation. And so they, the law went into effect in 2005. This paper started working in 2007. So they had a very small post sample. And that's still interesting for people to look at because everybody wants to immediately understand what the effect of the law is. But sometimes when we look back and look at a longer sample, we find that those results go away. So maybe there's two kinds of studies to be done there. One kind of looking immediately after the shock, look at a smaller window by necessity. And later with the passage of time, you have a longer window. And if the results don't hold for the longer window, well, there's an interesting paper right there. Right. I mean, that's my take.
Yeah, if I could just expand a bit on, I think, part of the theme of what we've just been talking about, not just the, in the context of pre and post the DID, but all of these techniques and approaches. And the thing that I want to jump on is sample size. And my limited experience in playing with and being involved in some of these projects is that's one of the big enemies that, and it's not just DID, that you can end up with really small samples. And I think it's it is what it is. We can't do a lot about it, but it does put pressure on us to maybe oversell what we can, if you look at the regression discontinuity, the whole idea is to take a small portion of the sample right around a discontinuity. And of course, we need to be careful about the inferences we draw, that it's sort of that localized effect. And even if you think of, say, that paper of Alexander's, the tax one, where you've got a bunch of different states with different taxes, and it's a great paper, and Tom's a big fan of it if I've tuned into the paper Tom was, the right paper Tom, the one I'm talking about that Tom was referring to. But, you have, in a sense, a sample size of 20 odd or 30, whatever the different number of tax treatments were, which is really impressive and, a great paper for us to sort of cling to. But in a way, we sort of, if you sit back and you say, I'm basing evidence on a sample that's like 20 or 30, how much further advanced are we in terms of getting to causality? So to circle back to the small question, it's sample size. What do the panel want to buy into the sample size issue? Small sample.
Mm-hmm.
Well, yeah, all the statistics is based on the bigger the sample, the better.
So when I'm not expert in this, but when I do diff analysis, I tend to show different variation of it. I look at 1 quarter, for example, depends of course on the data I use. I use quarter or a year before and a year and a half after, and 2, 2, 3, 3. So I try based on the data to show variation of the results. And truly, as Lalitha mentioned, sometimes this affect decay after a specific period of time, which is fine. You have still interesting result to show the immediate reaction to the changes where you look at the different depth. This is how I address that. Rather than restricting myself with larger and small, I show the story from too many angles. And I feel always when I show robust result, that there is nothing I'm hiding. I'm showing you everything. Result exists in some years, doesn't exist in others. And this is basically what we have.
Yeah, so we've been given, we started about 10 minutes late. So we've got, well, probably a little more than 5 minutes. There's a question I want to go to, but I just want to give everyone a warning where I'm thinking how I think we're going to conclude this. And I want a minute at the end just to wrap it up. And I want to be able to share the screen. Keith Woodward, I love your question. This is, to my mind, fantastic and super challenging. So, he said, regarding Linda's question about saving the situation versus doing the right thing, do you think that journals could help the situation by publishing the negative results regardless? Let me chip in. I'm interested in the panel. This circles back to what I think the rest of my career is going to be about, and it's going to be the bang on about responsible science. And it's not just, it's not a burden just on researchers. In fact, researchers can't lead the charge because it's career limiting to do too many things that are adventurous in the sense of how we do research. You were spot on. Journals and editors have to take a lead. They have to be adventurous and they have to take risks and they have to do things like publish replication. They have to publish non-results. They have to publish negative results. They have to make sure they're all quality. It's not, I'm not saying randomly publish stuff and we'll all be a better place. So the presumption is people do quality research, and if it doesn't line up with our current consensus, we need to know about it. And if we don't know about it and we hide it, or we just line up with what we think the incentives are, the world is a worse place. Journal editors have to take their gloves off and risk reputation in the short term, and we need to bring our colleagues along. You know, a part of me, I feel it's a disgrace. I think there is a crisis. So I'm going to hand it over to the panelists. They might not want to agree with me in saying controversial stuff, but I totally agree with you, Pete. We need to have less bias in publication, the work that's being published.
Yes, I agree. I agree with Robert.
I was just going to say, I think journals are perhaps, maybe this is just optimism on my part, but I think they're being a little bit more open to this idea of non-result, especially in fields that are new. So for example, I forget what they call them, but they're inviting a proposal and they vet the proposal. So if, for example, on climate risk, right? It's a new area, people are interested. And the RCFS had a recent conference also where they did the same thing. They had a number of papers where you submitted the proposal and the reviewers approved the proposal. And so then it didn't matter what the results were. They said, fine, we like your experimental setup, we like the question you're asking, so whatever the results are, we will still publish it. So there's an implicit commitment, or actually an explicit commitment to publish. So I think they're doing that for new fields, and maybe, you know, one hopes eventually it'll come to other fields as well.
Or yeah, I agree. That's one approach to it. Or Robert, you can start your journal.
Well, I don't need to start a journal. So there's a couple of things. I'm publishing replications already at the Pacific Basin Finance Journal. We've been doing this for 2 years. It's a crazy, crazy thing to do because what can happen? People are going to point the finger and say, did you see Pacific Basin? They're publishing replications. Reputation could drop, citations could drop. We had an experiment 2 years ago. Tom was involved in this, a number of others. We basically had our registered report approach to a special issue of Pacific Basin. And in fact, when I find the time, Pacific Basin, I've got Elsevier's approval. I'm going to start up registered report experiment, and hopefully we can get it embraced. And I'm going to try and put pressure on other editors as well, and see what happens. So, you know, I think someone like me can do this. I'm crazy. I'm nearer the end of my career at the beginning than I am at the beginning. So what can happen to me? Not a lot, okay? No one, apart from the mafia coming to tap on the shoulder, and hopefully that's not going to happen. No one can make my life as an academic a disaster, because if I get harassed and picked on, I'll just disappear and I'll retire. But this, so I'm getting, sorry, long-winded. And in fact, what I'd like to do, if you could share the screen, I think this is a good way for me to let me, so whoever's hogging the screen, you can let me, okay. I want to round things up, and while I'm finding the thing that I want to finish up on, let me thank the panelists for a fantastic session. I think there's a lot here for everyone to take away. There's some confronting stuff, there's some challenging stuff, but this is important, this is super important. And as I tried to sort of set the scene for this in my own way, the way I see what we're trying to do here is fit, the way I like to look at it, we want to be part of the wave of responsible science. And if we believe we're going to get evidence around causality, then we have to roll up our sleeves and do a much, much better job, and an increasingly better job as we go forward. So there's a little plug, and it's all around responsible science. I started in the last few weeks to create a research network. The theme will be responsible science. We've got a bit of a flavour for it. The sub-theme is research training and capacity building. In the space of a few weeks, I've got over 160 members. I've got 58 countries that are represented. I'm on a mission. If this resonates with you, send me an email. I would love to have people that are buying into this to be part of the journey. This could be a screaming failure, and if it's a failure, I'll sort of die knowing I tried. But I am going to try as best I can. I want to help as many young scholars as I can, novice researchers in research training and capacity building, to take on the research challenge in the 21st century. And responsible science is the way to go. And what I hope to do in that network is draw on a broad area of expertise from people that are broadly aligned with this theme to help us all move together to have the new generation embracing concepts and principles that are around responsible science. We want reliable evidence, we want useful evidence, and we want to be independent researchers. Send me an email, rfaff@bond.edu.au, and be part of it. If I haven't convinced you, I've tried my best, but I'll be happy to have you. Thank you, panelists. Thank you, everyone. I hope you enjoy the conference. I've enjoyed this session, and with that, I will stop sharing the screen, and if Bala has anything to say, or anyone else, happy to do it.
Thank you, the panelist and the moderator, Robert. So thank you for these outstanding sessions. And I started getting a lot of emails. How do we get these slides? And so I'm just writing to them. We will be providing the access to the slides, and we have also got the permission to record this session, and we are recording. We will edit the recording, then made it available in Retro webpage somewhere. So that's what I was telling, and a very exciting session. So thank you for everyone.